Hello, this is Wellington with PX5, and today I'll show you how to create and use a message queue with PX5 RTOS. So in this video, we'll run through the queue APIs, then we'll do a 3 minutes demo, then I'll share some resources. As a quick recap, we use POSIX message queues as a mechanism to provide communication between threads. These queues, as you can see here below, they are configured during the creation as per the maximum number of messages and the maximum message size. These messages also have priorities 0 to 31, and messages with the same priority will be retrieved with FIFO, or first in, first out. Threads can be suspended either trying to send messages to a full queue or trying to retrieve from an empty queue. This behavior can also be changed if we use the non-block property. Okay, with this review, let's take a look at the APIs. The first one is the MQOpen. So let's see how can we create a message queue using the MQOpen API. This process would require the MQ header and then a call to the MQOpen API passing the queue name, also the mode of operation. In this case, we should always specify both oCreate and oReadWrite. The non-block is optional and it will prevent threads from suspending on this queue. Then the mode, which is not currently used by PX5 RTOS, and the queue attributes. So these attributes will specify the dimensions of the message queue as defined by the structure members, the max messages and the message size, which should be previously defined. And then finally, we can check the return for errors. Next, once the queue has been created, we can use the MQSend API to send messages to it. We need the destination message queue, then a pointer to the source of message, the message size, and the priority of the message to send. Finally, we can check the return for any errors. And the MQReceive API, which is very similar, which would also require the source of message queue, the pointer to the source of message, the message size, and the priority of the message received. Also checking the return for errors. All right, it's demo time. And as always, main starts executing and creating variables, threads, and the memory area. Then on line 3, we create the attribute structure for the queue. Next, in line 7, we start PX5 RTOS by providing a random number for pointer data verification. We explained that in a separate video. Memory area and the size of that memory area. This will convert main into a thread that is running at the default priority of PX5 RTOS, or 16. And then next, we can define the maximum number of messages on the queue with the attributes. Then the maximum message size in bytes. And now, to create the queue, we use the MQOpen API call, passing the name of the queue, the operation, oCreate and readWrite, the mode, which is not used, and the attribute structure that we created before. Now the queue is created, and next, to create another thread, the child thread, all we need to provide is a handle to this new thread and the entry point for the new thread. Here we can see the child thread has been created, and it also has the same default priority, which is 16, same as main. It is ready and waiting to run. Back to main. Main will increment its counter variable, now at 1. And then it will send a message to the queue. To do that, it needs the queue name, the message. In this case, we're casting the counter variable to a character pointer, then the size of the message and the message priority. Notice that the message appears in the message queue, taking up the first space. Main will increment its counter again, now at 2, and add another message in the queue. There you go, number 2. Now we have 2 messages. Another counter increment and another message in the queue. Now the queue, as we can see, is full, but main will increment its counter again, now at 4, and we'll try to add that message, the number 4, to the queue. But since the queue is now full, the main thread will be suspended until there is space in the queue. Notice the last attempt to add a message to the queue created an orphan message, which is now sitting in the queue thread block. It didn't get deleted because the queue was full. As you can see, main has been suspended and it is waiting for space in the queue, and child thread is now running, and it will create 2 local variables. Then it will increment its counter, now at 1. Then it will try to receive a message from the queue. It will take message number 1 because it's first in, first out. It now proceeded to check if the size matches and if the content, the number 1 pulled from the queue, matches, which is on counter, which it does. But what is important to notice here is that as we remove the first message from the queue, the message number 1, the 4th message that was waiting can now fit here. Of course, if at this point, if main had a higher priority, it would preempt child thread and add another message to the queue. But that's not the case. They have the same priority, so child thread will continue executing. Now increment its counter again, and it will pull another message from the queue. Now it took message number 2, and we have only 2 messages left. Get another one, only 1 left now, increment the counter, and take the last one. Thread will now increment the counter, now at 5, and child thread will try to take another message. But since there's no messages left, the child thread will be suspended after this call. Now main can run again. Now main will add another message to the queue, but notice that the child thread will unblock as soon as main adds the first message to the queue. As we can see, child thread has been unblocked, but the message number 5, was not added to the queue. That's because this queue already had a thread blocked waiting for this data, which was the child thread. So this message number 5 is now in the thread control block for child thread, and the queue remains empty. Now main will add another message to the queue, like so, and now we can see the message in the queue, and this process will start all over again. That's the demo we had for today. As always, if you want to learn more, make sure to visit our website at PX5RTOS.com. You can always email us with questions, request for information, or a quote at info@px5rtos.com. Thank you for your interest.